if we have understood the concepts behind when a resistor is connected in an AC circuit, when a capacitor is connected in an AC circuit, and when an inductor is connected in an AC circuit, it is time for us to understand what resonance in an AC circuit is all about. So resonance, simply we are going to represent it in this form, but it makes a lot of sense to us. And this is very, very important. We need to know this. And this is where we have F naught. At this point, this is the current. The maximum current peak is somewhere here, right? So at this point, we have F naught is the resonance, okay? Is the resonance frequency. Frequency. We must understand this. Very, very important. And it's measured in Hertz, okay? Let's see. Let's see what happens here. Remember, this is the maximum current, and max. That is I max the maximum current. Our concern is to find out what happens. And when do we not say that resonance has occurred in an AC circuit? Resonance occurs in an AC circuit when there is surge of a maximum current. At that point, resonance occurs, and that's what we're trying to see. This is the maximum current, the peak. At this point, there is a resonance. Where is this resonance coming from? Interaction between the inductive reactance and the capacitive reactance. That is where the resonance is coming from. So let's see. Let's see. We have inductive reactance is equal to capacitive reactance. If we substitute the values of these, respectively, we have 2 pi FL is equals to 1 over 2 pi FC. Understanding this will help us to know how to evaluate F naught. And remember, there is F at this point, the frequency. It's different from the resonant frequency because we are plotting current against certain amount of frequency. But when there is the intersection, the varying current against the frequency gives us a maximum current at which there is an intersection known as the resonance frequency. So let's see what happens and how we can get this mathematically. So let's see if we do this, okay, we take cross multiplication because there is minus over 1 here. We take cross multiplication and we have 2 pi F L brackets. This goes to this side, becomes 2 pi F C. But before this, there is something I quickly remember that we need to do first. We need to redefine. Let our F become F naught. It means wherever we have F, we assume or take it to be F naught to correspond with the quantity we are looking for. So we go 2 pi F naught L for inductive reactance, and then 1 all over 2 pi F naught again, and C for capacitive reactance. At this point, we can now simply do something very simple. We take cross multiplication against each other, and we have something new. And that happens this way. Take note, 2 pi F naught brackets, and then we have 2 pi F naught C, that it close all equals to 1 times 1, because this one will move to that 1. Oh, I think that is clear, right? So let's see. It's going to become clearer as time goes on. All right, so let's see what happens there. We clear out this. How do we clear out this? It's very simple. We need to know that 2 pi times 2 pi is going to give us 4 pi squared. And we have 4 pi squared. And then F naught times F naught will give us F naught squared. And we have C against L. There should be L here. Of course, there should be L here. That is it. Now C goes against L. We have LC all equal to 1. we have established a very clear relationship that will help us, or that we can use to find the resonance frequency. But before I go on to find the resonance frequency, you need to go on and subscribe. You need to go on and put on the bell button for constant notification. You need to go on as well and then share with your friends and network. Students, do that for me. Support this channel. It belongs to this family of great teachers, great learners. Let's go back to it. So if we do this, we want to make F naught the subject. F naught squared is equal to 1 all over 4 pi squared LC. That's what we have. Look at it very well. It's very simple, right? Just watch it. Good. So the next thing, we square both sides. We square both sides. If we square both sides, we find the square root of both sides. Excuse me. We find the square root of both sides, and that gives us this, something new. 1 all over 4 pi squared, and we have LC. I want everything to end here. I don't want to clean the board. I want you to see everything as clear as possible. So this square, we take our square roots, and we're left with just F naught. I want to reduce this a bit. Pardon me, let me reduce it a bit. Good. So this can be F. Okay? All right? Now we have this. We have F naught. F naught is equal to, so look at this. Square root of 1 remains 1. All right? Square root of this becomes 4 pi. Look at it, 4 pi, all right, squared LC. Look at it very well. I have not changed anything, but something must happen here. We must split this, because certain quantities there have square roots, right? Their square root can be found. So we can find the square root of 4 pi squared. So let's go. We split further. We have F naught is equal to 1 over roots 4 pi squared, and then roots LC. That's it. That's it over there. We'll move on again the next step. F naught is equal to 1 all over square root of 4 is 2, right? Square root of this, it will cancel out. We have only pi remaining, and then we have roots LC. Good. Have we forgotten anything? Is there anything we are forgetting? Nothing at all. Look at it. Nothing at all. We are not forgetting anything. So what do you think happens here? That is the resonance frequency we are talking about. Can't you see we have found it? We have found it. Bravo! We have found the resonance frequency, F naught. So resonance frequency, F naught is equal to 1 all over 2 pi r, 2 pi roots LC. Does this tell you something? Is there anything you can get from this? The resonance occurs when there is what? An inductor and a capacitor. If there is a resistor offering some amount of resistance there, the resistance or the resistor will not be included, because resonance cannot occur when you have a resistor. A resistor is a power consuming component, just like I discussed in my previous video. Go and watch it. And that is why it is not included in here. So, what do? We have found this. This is absolutely interesting. Okay? Absolutely interesting. Look at it. So we can go on and explain further that 2 pi F naught is also equivalent to LC. 1 over LC, excuse me. Yes. 1 over LC. We can rewrite that. We can put it in that form. Okay? We can put it this way, that 2 pi F naught is equal to 1 all over root LC. We can do that. Nothing is wrong with that. What that tells us, we are talking about some kind of angular resonance. Okay, this becomes some kind of angular resonance, or omega naught is equal to 1 all over roots LC. My dear viewers, my dear friends, my dear students, my dear subscribers and returning subscribers, new subscribers, and community that love learning, look at it. We have finally arrived at a point we can now conclusively say, this is the resonance. So what happens? There is something we need to understand. At maximum current, look at the I mass. Don't mind my diagram. There is resonance. And this resonance, when the current is below the resonant frequency, what happens? Current is less, is small. And then when the frequency F is equal to the resonant frequency, you have maximum current. Take note of that. And I want to end it here. And thank you so much for your patience and for watching up to this moment. Before I let you go, please remember to subscribe, thumbs up, share, and then put on the bell button for constant notification. I sign out. See you in my next class.